Okay, we've now finished with polynomial functions and we're going to move on to sinusoidal functions. But before we do that, we need to discuss different ways of measuring angles. So this section is called Angular Measure, Degrees and Radians. It's section 5.4. We're actually going to do it over 2 days. And today what we're going to do is we're going to distinguish between degrees and radians. How are they different from each other and how are they the same? You know about degrees, but you might not know about radians yet. So the first thing we're going to introduce is a rotation angle. And what that is, it's an angle that's formed by rotating an initial arm through an angle about a fixed point. Well, that sounds confusing. So let's draw some stuff here and name some stuff. See this line right here? That could go on forever, by the way, in one direction, not both directions. You know what that's called, by the way, when you have something that starts at a point and goes forever? It's called a ray. So if you want, you can think of this as a ray going on forever or just a line segment. Anyway, this is going to be our initial arm, or our initial side, it's also called. And then what we're going to do is we're going to keep this end right here. We're going to keep it exactly where it is. So this is our vertex. That's not going to move. That's going to stay exactly there. It's like it's stuck into the ground right there. But what we're going to do is we're going to rotate this this initial side. We're going to rotate it around. Here we go. You can see there's actually two of them, one on top of each other, just to help you see this. So I'm rotating this around, and as I rotate this around, I could go like as far as I want. I can even go around multiple times if I want. But anyway, if I start back to the original spot, as I rotate around like this, do you see you get an angle in here? So that right there is called the rotation angle. This is the rotation angle. The way you form a rotation angle is by rotating an initial side through a fixed point, which is called the vertex. So this is the vertex here. And what you end up with here, by the way, is once you've moved the initial side to a new position, this is called the terminal side, or the terminal arm. Oh, it looks like I put side in the diagram and arms in the definition. Oh well. Terminal side and terminal arm are exactly the same thing. All right, much related to that is a standard position angle. So what a standard position angle is, it's a rotation angle, so it's just like this, except you're going to place it on a coordinate plane. Here's a coordinate plane, right? We have your 4 quadrants. You're going to put the vertex at the origin. So you see that vertex point right there? We're going to put that point at the origin, which is right here. And you're going to put the initial arm, here's the initial arm, it's going to run along the positive x-axis. Remember, this is the x-axis. It's not going to run this way, that's the negative x-axis. It's going to run this way. This is the positive x-axis. But besides that, it's exactly the same thing. All you're going to do is take that initial side, you're going to rotate it, and wherever you stop, let's say I stop all the way over here, then this would be your terminal side, and you get an angle forming right there. And that would be your standard position angle. Standard position angle. Now, two things, positive and negative. If when you rotate that initial side, you could rotate it this way, in which case you get a positive angle, or you could rotate the other way, in which case you get a negative angle. So to show you that, let's go back up here and I'll demonstrate what I mean, because this applies to standard position angles and also rotation angles. So if I take this, let's return it to the way it was. If I take this initial side and rotate it in this direction, that's counterclockwise, then no matter how far I go, let's say I stop right there, I get an angle forming in here, and this would be a positive angle. The reason it's positive is because I rotated in a counterclockwise direction. However, if I again take this and go back, and let's say I rotate this way this time, I'm going clockwise. And let's say I end up in exactly the same spot, right? That's exactly where I'd put it last time. But because I moved in this direction, a clockwise direction, I'm interested in the negative angle here. Okay, positive if you go counterclockwise, negative if you go clockwise. Okay, so what we're going to do is we're going to sketch some angles here. 150 degrees, and it's a standard position angle. Plus we have to state the quadrant in which the angle terminates. In other words, where's the terminal arm? So standard position angle, there's some stuff you can always do. You can always put the vertex at the origin. You can also always put the initial side running along the positive x-axis. So if you wanted to, you could do that for all of these right now. If it's a standard position angle, the vertex is at the origin, and the initial arm goes along the positive x-axis. Now, where's the terminal side, or the terminal arm? 150 degrees. So that means you'd be rotating this. If you rotated it up to here, how far have you rotated it? 90 degrees, so we need more than that. If you rotated it to here, how much have you rotated? 180 degrees. We need less than that. So would it be closer to 90 or 180? 150 closer to 180, so it'd be somewhere around there. In fact, it'd probably be even further down. I probably didn't go far enough. Anyway, let's not worry about that. This, make sure we draw that this is the angle, not down there. And that's approximately 150 degrees. So which quadrant is that? Remember quadrants? Quadrant 1 here, quadrant 2 here. This is in quadrant 2. The terminal arm is in quadrant 2. Okay, negative 300. Negative. So we're going to be moving this way. If I go to here, how much have I gone? I've gone negative 90. If I go to here, how much have I gone? Negative 180. If I go to here, how much have I gone? I've gone negative 270, so not quite enough. If I go all the way around, so I end up back here, how much did I go? I did a full 360. So we want more than 270 but less than 360. So it's close to the 270. It's probably somewhere up like that. And remember, the way you're going to draw this angle is not like that. That's not how we rotated it. We rotated it like that. That's negative 300 degrees. Which quadrant is this? That's quadrant 1. Okay, 500 degrees, that's positive, so we're going to go in a counterclockwise direction. If you go all the way around, you've gone 360. Maybe I better write this down, 360. If you then, so I've already gone all the way to here. Now let's keep going. I go up to here. How much more did I just go? I just went 90 more, so I'm up to 450. If I go another 90 down to here, that would take me to 540, which is too much. I want 40 degrees less than that. So it'd probably be almost in the middle, somewhere around there. I didn't get it exact, but close. And that's how you draw a 500 degree angle. Yes, you have to draw it going around all the way and then continuing on. You couldn't just draw this and call that a 500 degree angle. That's not 500 degrees. That's 140 degrees, I believe. Those are called coterminal angles because they end up with the same terminal side. But we don't need to worry about that in this course. Okay, now the big thing for today is radians. What are radians? Basically what radians are a different way to measure angles. So we've been talking about 150 degrees, it's negative 300 degrees, 500 degrees. And you know the basic idea with degrees is if you go all the way around, how many degrees do you have? 360 degrees. So basically what people did is they took the whole way around and they just broke it up into 360 pieces, and each one of those pieces they called a degree. So this was a human construct, right? This 360 degrees. It wasn't written in the stars, it had to be 360 degrees. Well, it's also not written in the stars that you need to use degrees at all. You can also use radians to measure angles. So how does that work? What a radian is, it's the ratio that compares an arc length to the radius of a circle. So let's try and explain that to you. Here's the center of the circle right there. I don't know if it really is. I'm doing the best I can. Let's draw a line, or a line segment, I suppose, from here to here. Now, what do we call that line? That line is the radius, right? It's the distance from the center of the circle to the outside of the circle. So this is a radius. And this radius is a certain length. We're calling it r. Now, let's say that we went along the circle a certain distance, and let's say that distance is the same distance as this distance here. So how could I label that red curve right there? I'd also label that r, because that distance there is the same as this distance here. Well, if you join the center to this end here, so you draw another radius from the center to the end of this curve, then the angle that results inside of there, right here, this is a radian. That's 1 radian right there. So when you only go part way around a circle, like this red curve here, that's called an arc length. And then you know what a radius is. So, as I said, if you want to know what the measure is of an angle in radians, you just take a measure of the arc length and divide it by the measure of the radius. So let's give you another example here. Let's say that I move this radius. Let's move it all the way around to, I don't know, there. And how about if we call this distance, the radius, let's call the radius 2. The radius is 2. And let's say once you start this arc length right here, from here all the way to here, let's say that that's 4. So how many radians is this then? Well, to get a radians, you take the arc length, which is 4, and you divide by the radius, which is 2. So this would be 2 radians, 2 rad. Okay? That's basically what it means when we talk about radians. So now, how many radians are in one full rotation? All the way around, right? When we talk about degrees, there's 360 degrees when you go all the way around. So how many radians are there when you go all the way around? Well, in order to figure that out, what's the arc length we'd need to consider? We'd want to look at the arc length, which goes all the way around. In other words, we want to look at the arc length that goes all this distance there, all the way around. What do we call that when you go all the way around a circle? We call that the circumference. So the number of radians in one full rotation is equal to however long the circumference is divided by the radius. Do you know what the formula is for circumference? Circumference is pi times diameter, or if we talk about radiuses, because that's more useful here, it's 2 pi r. Because 2 and r, I know it's weird because we separate them like this, but 2 times r is a diameter. So this is the same as pi times diameter, or 2 pi r. Divided by r, because that's the radius as well. Hey look, those cancel out. All you're left with is 2 pi. The number of radians in one full rotation is 2 pi. So another way we could say that, we'll just squeeze this in at the top here, is that 360 degrees all the way around a circle is equal to 2 pi radians. We can even get another simpler form of this. What if we divide both sides by 2? You end up with 180 degrees, or halfway around a circle, is equal to pi radians. Now that might be hard for you to picture, 2 pi radians. So remember, pi is just a number, right? It's 3.14 whatever. So 2 times 3.14, it's approximately, because pi actually goes on and on forever, it's an irrational number, it's approximately 6.28 radians. So when you talk about how many degrees there are in a circle, you say 360 degrees. When you talk about how many radians there are in a circle, you say 6.28 radians, but that's only approximate, or you say 2 pi radians. So you skateboarders and stuff, when you say, or snowboarders, whatever, and you say, whoa, see that trick over there? That guy just did a 360. Stop saying that. Instead you should say, whoa, do you see that trick over there? That guy just did a 2 pi. Because you don't even need to say radians when you talk about radians. You can just say 2 pi. Look at that. The guy just pulled up 2 pi over there. Okay, so believe it or not, the reason that we use radians, this is going to make you chuckle perhaps, is because using radians simplifies, this is right from your book, simplifies calculations. Now I know you're like, that is absolutely ridiculous. 360 degrees makes sense to me. 2 pi radians, I can't. It actually does simplify calculations, and this is especially true when you're working with sinusoidal functions, which we'll be dealing with in the next couple of days. Okay, let's say you wanted to know how much 1 degree is equal to. Well, then what you do is you divide both sides by 180. 180 divided by 180 is just 1, and pi divided by 180 is just equal to pi over 180. So with that in mind, if 1 degree equals pi over 180, how would you figure out how much 2 degrees is? You just multiply this by 2. How would, if you wanted to figure out what 10 degrees equals? Just multiply this by 10. So if you want to convert degrees to radians, what you're going to do is multiply the number of degrees by pi over 180. Similarly, what if you wanted to know how many degrees 1 radian is? Well, what you'd have to do is you'd have to divide both sides by pi. Dividing pi by pi just gives you 1 radian. Divided 180 by pi gives you 180 over pi. So you'd have 180 over pi equals 1 radian. What if you wanted to know how much 2 radians is? You would multiply this amount here by 2. What if you want to know how much 10 radians is? You'd multiply this amount by 10. So if you want to convert radians to degrees, you multiply by 180 over pi. So it's very important you remember that. For example, if I wanted to change these degrees into radians, we're going to use, and we want an exact value, so we're going to have our answer with pi in it. So we're going to multiply these amounts by pi over 180. So let's do that. 140 degrees, we want to change it to radians, so we multiply it by pi over 180. And what will often happen is you'll be able to simplify here. Look, we can multiply both of these, the top and the bottom here, by 10, and the zeros cross out, right? That's what happens when you divide by 10. 14 and 18, you could divide by 2. You get 7 here, you get 9 there. hey, there we go. We can get our answer now. 7 times pi is 7 pi, and then we divide it by 9. There's our answer. 140 degrees is the same as 7 pi over 9. Now, if you want, you can just write like that, 7 pi over 9, and if you're talking about angles, we know that's radians. Or you can also write rad or radians there to be really explicit that you're talking about radians. But if you write nothing, it means radians. That can be confusing sometimes though. Okay, same with negative ones, it really makes no difference. Negative 600, we're changing it to radians, so we're multiplying by pi over 180. Again, we could multiply by 10, or divide by 10, so the zeros are gone. 60 and 18, I think 6 goes into both of those. 6 goes into this 10 times, 6 goes into that 3 times. There you go, you're done. Negative 10 times pi equals negative 10 pi, and it's divided by 3. Negative 10 pi over 3, just leave it like that, or you can write rad or radians after. Okay, so now we're going to do the exact same question, but this time, rather than leaving their answer with pi in it, we're going to get a decimal answer. So we're going to round it to the nearest tenth. So I'm going to put 140 degrees. I'm going to write the same thing. I know this is ridiculous, but I'm going to do that. 140 degrees times pi over 180. What you could do is 140 times pi and then divide it by 180 and you'd have your answer. It's not too hard. But what if you forget the formula? You're just stuck with this 140 degrees and you're like, oh my gosh, I can't remember what to do in order to switch this into radians. There is a way to do this with your TI. Of course, you're going to have to remember this. But what you do is, first of all, you need to make sure that your calculator is in radians, the one you're ending up in. So if you look at mode, I clicked mode here, and if I go down to the third one down, I see that radians is highlighted, so that's perfect, that's what we want. So I'll hit second mode because that's quit, just takes us back to where we started. We put in 140, but we want this to be degrees. Right now the calculator is set in radians, we want it to be in degrees. So you see how it says angle right there, just above matrix? So what we'll do is we'll hit second matrix to get the angle. We want to tell the calculator that in this particular case, we're actually talking about degrees. So hit 1, and there you go. You can see it says 140 degrees. If you hit enter, it'll now switch it to radians for you. So the answer is 2.4 radians. And in this case, if I had, like, when you see a pi in one of these, it's kind of a giveaway that you're talking about radians. But if it just said 2.4, I think I would take the time to put rad or radians. Otherwise, it can be not so clear. Same with this one, negative 600. You could multiply by pi and divide by 180, or you could use your TI again. Why not? It's right here. So forget about the 6. Well, okay, we'll put the negative. Here's our negative sign, right? This is the minus sign, so negative. Negative 600. It's in the mode right now it's in is radians, so I want to tell it by going to angle here that I'm actually talking about degrees, so that's number 1. And then once I've done that, I just hit enter and it'll switch it. Negative 10.5 if I round it. So equals negative 10.5, whoops, I forgot the negative, rad. And there we go. Thank you very much, TI-83. Okay, change the following angle measures from radians into degrees. So if I want to change pi over 4 radians, and I want to change it to degrees, what do? Radians to degrees, multiply by 180 over pi. Whoa, this looks so confusing because the pi sign's right. Not at all. What happens when I multiply here? The pi's cancel out. All I have to do is simplify these two numbers. Well, I think I can divide them both by 4. 4 divided by 4 is 1, and 180 divided by 4 is 45. There you go, we have our answer. It is 45 degrees. Don't forget to put degrees. Same with this one, 2 pi over 3. We're going to switch it to degrees, so we multiply by 180 over pi. The pi's will cancel out. Nice. 3 and 180 can divide them both by 3, so that's just 1 down there. This is now 60. 2 times 60 equals 120 degrees. Once again, you could use the TI. Like, it's not going to be so useful here. Say I tried the same method, multiplying by 180 over pi. I mean, it'll work. Go 1.5 times 180 and then divide by 5. Pi, sorry. It's not that hard or anything, but there's no canceling out of pi signs here and everything, which is unfortunate. But we can also use the TI-83 for this. Again, if you forgot the formula, you could do this. Let's clear this. So first thing I have to do is I have to switch it to degrees. So I'm going to go down to the third one, go over to degrees, and hit enter. And now the calculator thinks it knows we're talking about degrees. We're going to write in the number of radians, so negative 1.5 3.5, and we need to tell the calculator we're actually talking about radians. So again, we go second angle, second matrix, I guess, and you see the R, third one down, we'll go down to that one, or just hit 3. You don't even have to go down to it. And if you hit enter now, there's your answer, negative 85.9. Negative 85.9, and we're talking about degrees. And the last one, 3.2 pi radians. So again, you could go 3.2 pi times 180 over pi, and it works out nice this time because the pi's cancel out, and then you just have to do 3.2 times 180, and how easy is that? Not hard at all, especially if you have a calculator. But again, if you've forgotten the formula, you could use your TI-83 again. You would make sure that your calculator is in degrees, and it is. We'd put 3.2 pi. The pi sign is right there, so I have to hit second and this up sign, and then I want to change the angle to radians, which is the third one, so hit 3, and if you hit enter, you'll get your answer, and it is 576 degrees. Now, there's just one thing I forgot to show you, and I would like to show you this. I think it's very useful. Thank Wikipedia for this. Okay, so I just want to show you, there you have, we've drawn a circle, here's the radius, label it R. Now I'm going to draw an arc length. This is kind of cool how they show this. See, this is the same length, obviously. They're going to curve it over. There's your arc length, which is the same as the radius. So here's your 1 radian right there. Now they're going to show you if you make the arc length twice as much, it's now 2 radians. Make it 3 times as much, 3 radians. A little bit more makes pi radians, right? 3.14, a little more than 3. That's what we said. 180 degrees is pi radians. If you go all the way around, 2 pi radians, which we also talked about, 360 degrees is the same as 2 pi radians. Okay, thank you very much to Wikipedia. You can see the link up here if you want to go find it yourself. All right, hope that makes sense. Have a good day.